I never think these lectures are as long as they are, and then I go back around the corner to the camera and I'm like, wow, 21 minutes? So apparently, I don't know, I guess I talk a lot or something, or maybe it just takes a long time to write crap down. So anyway, we're still in 3.3, 3.4, zeros of polynomials, and the next theorem we want is actually called the conjugate pairs theorem, and it's one that we actually just saw in the last example of part 1. But here's the theorem just so that you have it written down to help you out. So the conjugate pairs theorem says if a plus bi is a zero of a polynomial, which I'm just going to abbreviate poly, then its conjugate, a minus bi, is also a zero of the polynomial. Now, I really think that this theorem is only helpful for one situation, and I think that it's helpful for remembering to use your plus or minus sign, okay? So, and I'm gonna go with the most basic polynomial that we have. I'm going to say, what if we had x squared plus 4 equals 0? So you say, I'm going to subtract the 4 to this side, x squared equals negative 4, and I'm going to take the square root, So we're going to have an imaginary number. Hold on, you guys, I'm going to sneeze here for a second. Maybe not. It's there. Oh, well. We'll see. It'll probably just blow all over the board. We're going to take the square root, so we're going to have x equals, and on this side, we're going to have that imaginary number. So you write down 2i, but what is it that you might forget to write in front of the square root? The plus or minus sign. Now, for those of you that are already good with plus or minus signs and you never forget your plus or minus sign, you don't need the conjugate pairs theorem. But it basically says that the plus or minus will always come together. Always, always, always. Okay? So that's helpful. Okay. Now, the next one looks like this. It's called multiplicity. And it's not, doesn't have like a theorem name, but I guess it's a theorem, the multiplicity theorem. But this guy says this. If p of x is equal to x minus c times x minus c, we say c is a zero of the polynomial with multiplicity of 2. So what the multiplicity theorem, if we will, says is that every once in a while you are going to have a polynomial that has the same number as an answer a couple of times. So let's look at that right away. I hate to kind of blow the surprise for you, but let's look at that one. All right, let's see, where's my eraser? There it is. While I was waiting for the last lecture to load, I started to clean up the barn a little bit. You guys can't see it because I made it very clear that you cannot see all the messiness, but I did do a little cleaning in it. All right, what do I got here? X to the 4 minus 6x cubed plus 12x squared minus 8x equals 0. So first question is, how many zeros or how many factors is this guy going to have? And it's going to have 4, isn't it? Okay. So we know there are going to be 4 answers. So the next thing that we would do, or the next thing we would think of doing, would be the p's and q's. The problem is, though, is that there's no constant term, which means we can do something else first. We can pull an x out of everything, can't we? So we pull an x out front, and we have x cubed minus 6x squared plus 12x minus 8. Now, if we're looking for zeros of the polynomial, we have one right there. For our zeros, we'll just make a list of them over here. X equals 0 is one of them. 0 is a zero of this polynomial, which is fantastic. We're 1/4 way there. Now we've got to find the rest of them. So we're not working with the original, we're now working with this guy. So we're going to look at that and we're going to say, let's do the P's and Q's now because we have that constant. So remember, the P's are going to come from that constant, which is 8. So we'll go 1, 2, 4, and 8, right? All of the factors. And this one is another nice one because our only Q is 1, which means when we make our little fractions, okay, we've got plus or minus 1, 2, 4, and 8. Nice. Okay, so now if I was in front of you guys right now, I would ask you where you want to go. Who do you want to start with? Someone on the list. You know, do we start with 3? No, it's not on our list. So I'm just going to pick willy-nilly and I'm going to say, let's start with -1. Okay, it's got to be someone on our list. Let's see. So do we need any placeholders? No. So we're going to go 1, -6, 12, -8. So we pull down a 1. That makes -1, which makes -7. Which makes 7, which makes 19, which makes -19. This didn't work, did it? Okay, didn't work, so we crossed out. It's definitely going to happen. You're not going to get them all on the first try. Now, I know what the answer is, so you can fiddle around with as much synthetic division as you want, but why don't we try 2? So again, we're going 1, -6, 12, and -8. So bring down the 1, put a 2 here. That makes this -4. -4 times 2 is -8. That makes this a 4, positive 4, which makes that an 8, and lo and behold, there we go. Woohoo! Okay? So we can add the 2 to our list of zeros. Now, we found 2. There are 2 more. Where are they coming from? They're coming from this, right? And now we're down to a quadratic. So we can rewrite this as x squared minus 4x plus 4 equals 0. And luckily, unlike the last one, this one factors nicely. Okay, the 2 numbers that multiply to be 4, but add or subtract to be 4 are 2 and 2, aren't they? But I need a -4, so they both need to be negative, and that gives me a positive 4. So here, the 2 answers are 2 and 2. We already have a 2, and now we have another 2 and another 2. So I write them down as many times as they showed up. 0, 2, 2, and 2. And that way, everybody knows I found them all. There were 4, I found them all. If you had just left it like this, there might be some people that go, wait a minute, there's supposed to be 4 and you didn't find all of them. Okay, so you can tell people that there was multiplicity 3. So 0 was an answer and 2 had multiplicity 3. Okay? That's how this works. All right, let's look at another one. Theorem up there. Let's see what I have this time. Oh, we got to do this one. All right, 2x to the 4th plus 5x cubed plus 3x squared plus 15x minus 9 equals 0, sorry. So 4 answers to this one, right? 4 zeros, nothing to factor out. So we immediately go to our P's and Q's. All right, so our P's come from that 9 at the end, plus or minus 1, 3, and 9. Okay. And the q's come from the beginning, which is 2. So we have 1 and 2. So this guy is going to have some fractions. So p's over q's would be 1 over 1, 3 over 1, and 9 over 1. So 1, 3, and 9. Okay. And then fraction-wise, we're going to have 1/2, 3 halves, and 9 halves. 1/2, 3 halves, and 9 halves. Okay, now it comes to the point where you want to take maybe even push pause here and, sorry, I need a drink, and try some synthetic division. Try to find the first one. So push pause, try to find one, and then come back and unpush pause. I'm not going to waste our time. I'm going to go right to the one that I know is the answer. So I know that -3 works. So let's say I tried 1, -1, 3, -3. I finally get one that works. I don't need any placeholders. So we're going 2, 5, 3, 15, and -9. Bring down the 2. That's -6. That's -1. You see how fast this gets going? That's going to be 3. That's 6. That is -18. That is -3. That is 9. That is 0. Okay, so again, make a little list over here. Zeros. And -3 is on our list. Now, we have 1. We need 3 more. So where are the 3 more going to come from? They're going to come from here. But this is not yet a quadratic. Okay, so this is not a quadratic. So we need to keep doing synthetic division until we can get it down to a quadratic. But when we go to do the synthetic division again, we're not going to use the original numbers. We're going to use the new numbers. So we're going to go new numbers. The quotient is what we're using. So we make our synthetic division box, and we're going to go 2, -1, 6, -3. Remember, this is the remainder, so we don't need it. Okay, so now we have our list. Start plugging away, practice, practice, however many ones you want to practice before you push pause and practice. And then, lo and behold, come back, and I wonder what the answer is. I think it's 1/2. So, bring down the 2. That makes that 1. That makes that 0. That makes that 0. 6. 3. 0. Wow, lo and behold, how did I know 1/2 was 1? Well, the way I know that is because before I did this, I practiced them all and found all the answers by making sure I went through all of these guys. And let me be clear, there's no like magic trick that I'm going to teach you at the end of this lecture. The way I found these was by going through and doing synthetic division. Okay, this is a crappy type of problem that we have to do, but it has to be done this way. There's no shortcut to this. I wish there was. I wish someone would say, "Oh, did you know?" But it doesn't work that way. Okay, so this is exactly the way I'm doing it. If I was doing it, in real life, okay, which is real life. So yeah, I'm doing it. So 1/2 is a 0. Now that means the other answers are coming from here. And now it's a quadratic. This guy is 2x squared. It doesn't have an x term. Plus 6 equals 0. So if we subtract the 6, we have 2x squared equals -6. Divide by 2, so we have x squared equals -3. And we're going to take the square root. And here comes the conjugate pairs theorem. Plus or minus I square roots of 3, right? Because we can't do anything with the square root of 3, but we can bring out the I. So there's the conjugate pairs. We got the plus, we got the minus. So we have plus or minus I times the square root of 3. Alrighty. So 4 answers. We know we're done. We got it. So we're using these theorems to help us make picking them off of this list easier. That's the only thing we're doing. And the list is there just to help give you some guidance. It obviously doesn't give you the answer, but but the answer was on, they were on the list. I know that we don't ever have to try 6. I know we don't even have to try 2. 2 might be a go-to number. People like the number 2. It's not on our list. It's never going to work. So the list helps us, but that's all it is. It's just help, and then you have to do the work to get there. Okay? Now, there's one other theorem here that's called Descartes' rule of sign. And it does give you a little bit of extra guidance, but it is a very, very tricky, ugly theorem. And we weigh it as to how much help is it, as to how difficult it is. And the help that it gives you is minimal compared to how difficult it is. So we're gonna skip it. Okay, if you wanna read through it, have at it, but I think I've given you enough that you can be pretty successful with these guys. So give them a try, and we're good to go. All right.